Hi, this question is about the conservation of energy from the topic A.3 Work Energy and Power from your IB curriculum. And we are going to consider the energy transformation from the elastic potential energy to the kinetic energy. And so let's suppose that this is a original length of the spring L0. It's a equilibrium length of the spring. And what we did, we attached a mass with it and we compressed the spring. So we have given it energy, and this is a new length. So what is the extension value or what is a compression value? That is, so we compress the spring by this distance y, which you can also consider the amplitude, because this is the maximum distance by which we have compressed the spring. So when you were compressing the spring, how the energy was incrementing in the spring, and then how the energy is delivered to the object with which it moved, and it acquired the kinetic energy. That's what I will explain you in this video. So what happened in the question, it is clearly mentioned that the distance y, the force will increase. So if I take on a y-axis the spring force, and on x-axis I'm going to take a distance. So how the spring force is increasing as you are compressing the spring more and more. So this should be a straight line. Remember that I'm just taking a magnitude of the force as well as the distance. Otherwise, according to the Hooke's law, you know very well that F is equals to the negative x. So that should be the straight line, but like this straight line. And this distance here represents the compression distance of the spring, that how much you have compressed the spring. So if I want to know what is the total work done on a spring, because that work done is equals to the gain in elastic potential energy, because then that elastic potential energy is converting into the kinetic energy of this object of mass m. So let's find it. So work done is equals to the gain in elastic potential energy. So according to the question and diagram, what we see that we have compressed it to the distance y. Okay. And when we compress to the distance y, that is our amplitude as well. At that moment, the force in a spring is maximum, and that force is obviously ky. So if you find out the area under the graph, which is obviously this area, so that area represents the amount of energy stored, which actually is coming from all the work done, right? So if you find out this area under the graph, that would give you the total amount of elastic potential energy stored in a spring. So right at this position, the spring have the maximum energy stored, which is obviously coming from the work done. So that work done is equals to 1 over 2 half of the base and the height of the triangle. So what you get is 1 over 2 ky square. So this is the total elastic potential energy stored. And when you will release it, so it has a speed v. That's why right at this position it have the kinetic energy ek is equals to 1 over 2 mv square. So simply this elastic potential energy converted into this kinetic energy if there's a no friction at all. So finally, we are so close to find out the speed when the block will be released from the spring. So that is half mv square is equals to 1 over 2 ky square. You can just simply solve it, and mv square is equals to ky square. Okay, one half is cancelled from both sides, and we want to find the speed. So we can divide mass on both sides. So ky square over m, and then you can take the square root of on the both sides, so it will be equals to the square root of k over m into y. So finally the option a is the right answer for this question.